Okay, good morning everyone. Myself Dr. T Srikanth from CSE department. Today I am going to explain about propositional logic and proof techniques in discrete mathematics. So here first we will see. So in this we are going to discuss about what is propositional logic, syntax, semantics, validity, and basic connectivities and truth tables and logical equivalence, and we are discussing about rule of inference and different normal forms. So what is propositional logic? So proposition logic, proposition is a declarative statement which can be, it must be either true or false, but not, it cannot be both true and false. So we use T denotes to true and F denotes to false. Proposition variables are P, Q, R, S. Truth table's value result will be truth indicates 1, false indicates 0. So for example of propositions, Paris is in France, so which is true, the statement is true. London is in Denmark, which is false statement. Similarly 1 plus 0, if you take binary numbers, 1 plus 0 always will get 1 only, that is true. 0 plus 0, that is false, always will get result as false. Next 2 plus 3 is 5, that is true. 2 plus 3 is 8, that is also false. So in that way we can write the statements. Sun rises in the east and sets in the west. So which is also, those are the examples for the propositions. Now we will see here, these are some of the examples which are not propositions, but these are questionnaires, declarative. These are the questionnaires. Sit down. What time is it? X plus 1 equals to 2. X plus y equals to z. 2 plus 3, solve the equation 2 plus x equals to 3 and 2 plus x greater than 8. These are not propositions. So generally there are in propositions or statements are basically two types. We have two types of statements: atomic statement and compound statement. Atomic statement which cannot be further divided, compound statement which can be further divided in order to obtain the solution. Now we will see the connectivities. What are the different connectivities we are using in order to obtain the some formulas. So here connectivity is basically which is a logical operator which can be used to connect the any two statements. So here we have 5 basic connectivities are there. One is negation and conjunction, disjunction, implication, biconditional. So here negation is also we can call it as a not, which is represented with the symbols like. So here we can use so this symbol, we can use this symbol, or we can use bar symbol, or these are the symbols we can use for representing the negation. So for conjunction we can use the AND operator represented with the notation as like this, and disjunction we are using the OR operator. So here conjunction provides the product, disjunction provides the sum which is represented with as a OR notation, and implication represented with the imply symbol, and biconditional which can be represented as a bidirectional arrow. So first we will see what is the negation. Negation is also it is denoted by a symbol called like this. We can represent it as a this notation. So which is always which is also called as not. If P is a statement, the negation of P is like this. We have to represent like this. For example, P is a, these are the some of the examples which we are discussing. Peter has books. So this is the given statement. So if I want to represent same statement in with the help of negation, so I need to represent it with the notation negation P. Peter has no books. That is the in this way we have to represent the negation. So Onida is a good company. So that is a given statement. So if you want to represent that statement in negation, Onida is not a good company. So in that way we have to represent the negation. So truth table. So here truth table is a mathematical table used to determine if a compound statement is true or false. So here we have to use the 1 represents for true and 0 represents for false. So in a truth table each statement is typically represented by a letter or variable like P, Q, or sometimes we can represent it with 1 and 0 also. So here this is a mathematical representation for truth table. So here we in negation we are using the P is a statement here. So here we have P and negation P. For example, if a statement is true, then negation of P is false, obviously. So if the P statement is false and negation of P is true. For example, here we have 1 and here negation of 1 is 0. So for example, here we have a statement as 0, then here we will be having the 1. In this way we have to represent the truth table for negation. So next one is conjunction. So conjunction basically which provides the which is represented with the AND operator. Joining two statements with the AND is a conjunction. It is denoted by AND operator. So basically conjunction of P and Q will represent the one truth table, that is it can be represented as P and Q. So here we have two given statements, P and Q. So P is a statement and Q is a statement, and the result would be P and Q. So here if the both results are true, then result will be true. Remaining all cases result will be false. So, for example, here we have like this: true true, true false, false true, false false. So what is the result here in conjunction? If the both statements are true, then the result will be true. Remaining all cases it has to be false only. So in that way we are representing the conjunction. Next, disjunction. So disjunction which is represented as represented with R symbol. So joining two statements with R is a disjunction, which is denoted by R operator. So here disjunction of a P and Q is denoted as PRQ. So denoted as PRQ. For example, here we have statements are given like this. So P, first statement is Anne is on the softball team, Paul is on the football team. So for example, I need to represent these two statements in with the help of a disjunction function. Disjunction. So here Anne is on the softball team. Here which is represented with disjunction is represented with R notation. So I need to use the R. Paul is on the football team. Same here. For example, PRQ. What is P? P is a Anne is on the softball team. So here we have to denote it with the R notation, because of which we are using the disjunction. So and next statement is Q. What is Q? Paul is on the football team. So in this way we have to represent the disjunction. So another example is Japan is a country, Onida is a good company. So if you want to represent these two statements in disjunction with the help of R operator, which can be represented as result as Japan is a company, R notation, Onida is a good company. So in this way we have to represent the disjunction. Now coming to the truth table. So here, if both statements are false, the result will be false only. Remaining all cases, the result would be truth only. So here, if you see, here we will be having the two statements. One is P, another one is Q, PQ, and the result would be PRQ, because we are using the disjunction. Here, if the both statements are false, if P and Q are false, a result would be false only. Remaining all cases, result will be true only. In that way we have to represent the truth table. True true true, true false true, false true true, false 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 only. If the both statements are false, then result will be false only. Remaining all cases, result would be true only. Next, implication or conditional statement. Sometimes we are calling it as an implication, sometimes we are calling it as a conditional statement, which is represented with the arrow. If P and Q are proposition, then P implies Q is a conditional statement or implication, which is read as if P then Q. If the first statement is if P is okay, then it will be next we have to proceed the Q. So how we are representing? For example, we have two statements. The first statement would be you work hard. The second statement is you will pass the exam. So P implies Q, which is represented as P implies Q. P implies Q. So what is the first statement? If you work hard. Why? Because here we are using if then. If P. What is the P? You work hard. Then we have to use the then. What is the next statement? Oh, you will pass. So here we have to use if then. Here this is P and this statement is Q. If you work hard, then you will pass. So in that way we have to represent the implication or conditional statement. So another example is P and Q. What is P? An integer is divisible by 9 and Q is the sum of its digits is divisible by 9. So P implies Q. If an integer is divisible by 9, then the sum of its digit is divisible by 9. So in this way we have to represent the implications. So now coming to the truth table. So here in truth table, if the first statement is true and the second statement is false, then the result will be false only. If first statement is true, second statement is false, then the result is false. Remaining all cases true only. So here see, observe the truth table. So here we will be having two statements P and Q, and the result has to be represented because this is implication. P implies Q. If the first statement is true and the second statement is false, then the result will be false. Remaining all cases, result would be true only. So in that way we have to represent the truth table for implication. Next, by implication or by conditional. So here if P and Q are propositions, then biconditional Q is a biconditional statement or by implication, which is read as P if and only if Q. P if and only if Q. So which is represented like this notation. So here we have to use PIFF. So this is the if and only if, which is represented as biconditional statement. P, Q, these are the two statements, and notation is represented with biconditional, that is double arrows, bidirectional arrow. So here now I am taking the two statements. The first statement is P, I am breathing. Second statement is I am alive. How we will represent this into biconditional? I am breathing if and only if I am alive. So in this way we have to represent. So I am breathing if and only if I am alive. So in this way we have to represent the biconditional statement. Next, we will see one more example. So we have two statements P and Q. P is you passed the exam. Q, you scored 65% or higher. So here how we will represent these two statements in biconditional? If you passed the exam if and only if you scored 65% or higher. So if and only if we have to represent if and only if in biconditional. Biconditional Q means that P and Q are equivalent. P and Q are equivalent. So the double implication is true. That means in a truth table how we are representing, if the P and Q both statements are same, then the result will be true. Remaining all cases, result will be false only. See here, what is biconditional? If the P and Q both statements are same, then the result is true. Remaining all cases, false only. So observe the truth table. So here we will be having the two statements P and Q. If both statements are according to the biconditional, we have condition as if both statements are true, result will be true. So here both statements are same, the result will be true. So here both statements P and Q are true. So here also false. Here both statements are same. If the both statements are same, result has to be true. Remaining all cases, result would be false only. So here we have to remember all these statements in order to solve the problems. Next, tautology. So tautology is a formula which is always true for every value of its propositional variables. Tautology is nothing but always it has to produce the true only. In result table, truth table, result must be true only. So this is the one sample example, a truth table for tautology. So here we have two statements. One is P and another one is negation P. If P is true and negation P is obviously false only. If P is false and the negation of P is true, because it is not simple. So P or Q, P or negation of P. So that means true, false. If you are using R notation, if any one of the statement is true, result would be true only. So in this case here result is true, so here also true. So in the truth table, if we got all statement as true, then that is called as tautology. Next, contradiction. So contradiction is nothing but a proposition that is always false is called as a contradiction. So a proposition which is always false, the result truth table must produce false statement. That is always in truth table, always if the false conditions we have, then that is called as, the truth table is called as contradiction. See here, so where earlier we used R notation, now I am using AND operator. So here we have P and negation P, true, false. True, false, if you are using AND operator, what is AND operator denotes? If both the statements are true, then only true. Remaining all cases, the result will be false only. So here true, false, 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 true, false only. So here observe, in this column, we have all statements as false only. If the all statement values are false, then the truth table is called as contradiction. Next, contingency. So contingencies have both T's and F's in their truth table, means which contains both truth as well as false. A sentence is called as a contingency if the truth table contains at least one true and at least one false. Truth table must and should contains at least one true and one false. Then only that table is said to be contingency. See here, we have P and Q, two statements are there, P and Q. These are the two statements. First statement is P and the second statement is Q, P and Q. So now I am taking these statements values as true. First statement as true, 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 false, false, true, false, false. Now here I am applying the PRQ. So here I am using the R notation, PRQ. So what is R operator does? So if any one of the statement as true, the result will be true only. Remaining all cases, the result would be false only. So here both statements are true. So here it will provide true only. So true, false, obviously true only. False, true, true only. False, false, false only. See, observe here in this column we have trues as well as false. If in a table, in a truth table, resultant table, we had trues as well as false, then the table is said to be, then that statement is said to be contingency. Then that statement is said to be contingency. Next we will see some examples on connections, how we will do with the help of all the statements what we have discussed till now. So we have a statement called now, formula called negation of P and P implies Q. So here we have total, we have two statements are there, P and Q. So two variables, that is P and Q. So P and Q. So here we are having negation P, and as well as the next statement is P implies Q, P implies Q, and the final one is negation of P and operator P implies Q. So here simply we can say that P implies Q. What is implies? Implies means conditional statement. What is conditional statement? So in conditional statements, if any first statement is true and the second statement is false, and the result would be false only. Now take the we have taken P and Q. So true, 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 false, false, true, false, false. And negation of P. Negation of P means simply we have to take the negation value of true is false, true, false, and false, true, false, true. So P implies Q. So implication. What implication will do? Conditional statement. If a first statement is true and the second statement is false, then the result would be false only. Remaining all cases true only. So that's the reason we have represented as like this. Next, now we have to perform the AND operation on these two. False, true, false. What is AND operation? If the both statements are true, result would be true only. Remaining all cases false only. False, true, false only. False, false, false only. True, true, true. True, true, true. In this way we have to represent the examples on connections. Similarly, P implies Q or Q implies P. So this is another statement, same procedure. Next to tautology. Simply see the result. We will be having tautology. According to tautology, what is tautology? So it must have in a truth table, in resultant table, we must have compulsorily all values must be true only. If all values are true, then that is tautology. If all values are false, then that is contradiction. So in this way, in that way we have to represent the tautology and contradiction and contingency. Now we'll see the converse, inverse and contrapositive. So if you interchange the antecedent and the consequent of a conditional, you form a new conditional known as the converse of the original statements. First we have to take the original statements. If you interchange the values, then you will get the converse. If you negate both antecedent and the consequent, you form the inverse. So if we apply the negation on both statements, that is, for example, P implies Q. If we have represented negation P implies negation Q, then that statement is said to be inverse. For example, P implies Q in converse. So what we have to do, simply have to interchange the values. P implies Q is interchangeable to Q implies P. Then that such statements are called as converse. Next, contrapositive. So in contrapositive, simply you have to interchange the statements and you have to give the negation. Then there are such statements are called as contrapositive. See here, conditional statement which is original, P implies Q, if P then Q. Next, converse. Converse means simply we have to interchange the statements. Q interchanging means how we are interchanging, just we have to interchange this Q and this P here. If you interchange the Q and P, then simply that statement is said to be converse. Next, inverse. Inverse in the sense, simply you have to give the negation on both original statement. For both statements you have to give the negation symbol, then that statement is said to be inverse. Next, contrapositive. Contrapositive means first you have to interchange the both the statements, and if you give the negation on both the statements, then such statements are said to be contrapositive. In that way, we have to represent the converse, inverse, and contrapositive. For example, we will see with one example. We will discuss all this what is converse, inverse, and contrapositive. So, original statement. What is the original statement? If water is frozen, then its temperature is below 0 degrees. That is the original statement. So now I want to represent the same statement in with the help of the converse. So what is converse? Now here this is P and this is Q. So that is P implies Q. What is P? P is a water is frozen. What is Q? Then temperature is below 0 degrees. So now we have to apply the converse. Converse means simply you have to interchange the values. Interchange the values in the sense you have to represent like this. Q implies P. What is Q statement? So Q statement is temperature is below 0 degrees. If the water temperature is below 0 degrees, then it is frozen. So frozen is the first statement from the original statement. P is it is frozen. What is Q? Temperature is below 0 degrees. So in this way we have to represent the converse statement. Now inverse. So inverse in the sense, first you have to take the original statement, you have to apply the negation on both statements, then the statement is said to be inverse. So how we will represent? Simply negation P implies negation Q. What is P statement? P statement is generally, what is P statement? Frozen. Water is frozen. If water is not frozen, so because here we have to use the negation in inverse statement, we have to use negation, that is not frozen. If water is not frozen, here this is negation. If water is not frozen, this is P. This is P. If water is not frozen, then temperature is not below 0 degrees. So then this is called negation of Q. Negation of P, negation of Q. In that way we have to represent the inverse statement. Next, contrapositive. So contrapositive means first we have to interchange the P and Q, that is Q implies P, Q implies P, and both the statements you have to apply the negation. You have to apply the negation on both sides. Negation Q implies negation P. So what is Q? Temperature is below 0 degrees. What is P? Is frozen. That what is it? Frozen. So if we apply the negation, if the water temperature is not below 0 degrees, if the water temperature is not, that is negation of Q. If the water temperature is not below 0 degrees, then it is not frozen. So in this way we have to represent the contrapositive. Next, one more example. So here we have two statements. The first statement, that is P, so which is represented as, which is if a figure is a square, Now what is second statement? Then it is a quadrilateral. So converse. What is converse? Simply you have to apply the, you have to reverse, you have to interchange the statements. So if a figure is a quadrilateral, this is Q and this is P. Now we have to interchange the, here this is represented as Q implies P because that is converse. We have to interchange the P and Q. If a figure is quadrilateral, then it is a square. So now this is Q and this is P. Q implies P. That is, if we are interchanging the two statements, then that is said to be converse. Next, inverse. Inverse in the sense, simply you have to give the negation on both statements. That is negation of P. What is negation of P? What is P square? That means if a figure is not a square, then it is not a quadrilateral. That is called inverse. Next, contrapositive. First you have to interchange Q and P, then you have to apply negation on both sides, then that statement is said to be contrapositive. So here this is Q, this is P. Here we have to apply negation on both sides, that is not. If a figure is not a quadrilateral, then it is not a square. So in this way we have to represent the conditional. First you have to take the original statement, that is conditional statement is said to be original statement. Converse, inverse, contrapositive. Next, syntax of proposition logic. So generally, here using logical connectives and operators which connects or operate on propositions. Here we have to use some logical operators which are used to connect the two or more connect the two statements. Symbols. What are the symbols we are using? Using letters. We can use different letters P, Q, R, X, Y, Z to stand for specific statements. So here we can use the unary proposition operators, that is called negation, because negation can be applied on either P or Q only. We cannot apply both statements. So that's why this is called as unary proposition operator, negation. Next, binary propositional connectivities implies biconditional, OR operator, and this is AND operator. So here this is not this one. So this is AND operator, like this we have to represent. So we can use the grouping symbols, that is parentheses and brackets. So here we will see some syntaxes. Negation. So already we discussed some different notation. Negation is represented with the negation symbol. So like this. Negation. Conjunction, which is represented with the AND operator. Disjunction, which is represented with OR operator. Conditional, which is represented with the implication. If then. Next, bicondition, if and only if, or IFF, IFF, we can use both, either if and only if or IFF. So which is represented with the symbol, bidirectional symbol. So here P bidirectional Q, P implies Q, P and Q, P or Q, negation P. In this way we have to represent the syntaxes of proposition logics. Negation already we discussed, negation, conjunction, disjunction, conditional, biconditional. And in order to solve the problems, we need to we need to have some idea about these laws of logics. So here generally we have equivalence statement as well as name of the identity. So first we have identity law. Identity law, that P and T equals to P, P are false equals to P. Next, to domination laws, P and false equals to false, P are true equals to true. Next, to idempotent laws, P and P equals to P, P or P equals to P. Next, double negation of P equals to P only. Commutative laws and associative laws, distributive laws, De Morgan's laws, observation laws, negation laws. So with the help of all these laws, we can solve the problems. Now we will use some standard formulas. P implies Q, P implies Q. P implies Q, which is denoted as negation P or Q. P implies Q is nothing but negation P or Q. P double implies Q, that is biconditional. P biconditional Q, which is represented as P implies Q and Q implies P. P implies Q and operator you have to use Q implies P. P or Q and R or Q can be represented as P and R or Q. So these are the three standard formulas. Addition to that logical laws, we have to follow these standard formulas in order to solve the problems. Next, replacement process. So replacement process. So here we use the logical equivalences about to show that negation. Here we have to, in order to solve these problems, we have to replace we have to use some logical laws in order to replace the existing statements. How we will solve? We will see with one example. Negation of P. This is the given statement. So negation P or negation P and Q is a contradiction. So contradiction means resultant table, truth table must contain final result as false. If it is false, then that is said to be contradiction. If the resultant is all truths or final statement is true, then that is said to be tautology. So here we will see how we have to prove this to be contradiction. The statement must be contradiction. How we will solve? By using some different laws and replacement statements. Negation of P or negation of P and Q. So here now I am applying the De Morgan's law. So what is De Morgan's law? Simply how to, if we have R operator, this is like P or P and Q. So if the both operators are different, then we can apply easily the De Morgan's law. Negation P. So this is like this. Negation P and negation of P and Q. So now simply we are applying the De Morgan's law. So here De Morgan's law means we have to apply the negation on we have to simplify this one, negation of P. So here whenever we are applying the De Morgan's law, negation means here R operator will be converted into AND operator, and then we have to apply the negation on the next statements. Negation of negation P and Q. So here these two negations be cancelled, then we will get negation of P. This R operator will becomes to AND operator, and we will be having the P and Q. So by using the double negation law. So here double negation means negation will becomes to get cancelled, then we will get only P and Q only. So here De Morgan's law means simply how to apply the negation. If we simplify that one, negation of P, R symbol will becomes to AND operator, and we have to apply the negation on this statement. Both negations will be cancelled because of double negation. Then finally we will get negation of P and Q. Now again here we can simplify using the association law for this statement. Then it will be P and Q can be represented as these two statements and Q. That is negation P and P and Q. So like this, these two statements will be combined, and this will be additional, another one. So negation according to the domination law and commutative law. So domination law, what is domination law? Negation P and P is said to be false. Negation P and P is said to be false. False and Q is always, from the commutative law and domination law, false and Q is always false only. So now hence that statement is proved. So given statement is a contradiction. We have to prove that given statement into contradiction. That means final result must be false only. So we have proved. So the statement is said to be contradiction. So this is about the today's session. Thank you very much.